Alright, trying out this problem called online stock span. It's a big problem to read at least. Let's have a quick read. Is an algorithm that collects daily price quotes for some stock and returns the span of that stock's price for the current day. Okay, let's try and understand what that means. Span of the stock's price in one day is the maximum number of consecutive days starting from that day going backward for which the stock price was less than or equal to the price of that day. For example, if the price of the stock in the last 4 days is 7212, then the price of the stock today is 2, then the span of today is 4. Stock for which the stock price was less than or equal to. So 22212. Yeah, so 3 should be 3, no? Because starting today the price of the stock was less than or equal to 2 for 4 consecutive. So you count today as well, okay? Also, the price of the stock in the last four days is this, and the price of the stock today is 8. Then 821 again, so 8213. Yeah. This is quite basic problem. I think this is just on the left side. You're trying to find the on the left side. So you're starting from this point. You're going on the left, and you're trying to find the next greater. Right. That is all you're trying to do, really. Also, if the price of the stock in the last 4 days is 73412, and the price of, oh yeah, all of it, right? Implement a stock spanner class. Stock spanner initializes the object of the class, and next returns a span of the stock's price given that today's price is price. Okay, so something I'm missing. Okay, but let's look at the example. Maybe that's clarifying. So stock spanner, next. Okay. So initialize your stock spanner class, fine, and then you have to maintain this next or int somewhere, right? So you go 100. So you save this 100 first of all, and you return 1. Then 80, return 1, and 60. So you have to add this in this specific order somewhere. How do you maintain this? Do I keep a list? So here maybe I do this. So I maintain an array list uh, of integer list, and I initialize it here. So list equals to new array list, and here what you do is so you do list.add price, okay. So and then when I call next, I can just go, because you're calling next every time, I can just um, this is interesting. Like, does it have to be better? Like, does it have to be better than O of n? Interesting. Like, obviously, I could just walk back, right, the list, and so every next will be O of n. I mean, that's obviously one solution. I'm thinking if it is better. Like, instead of saving it in the list, do you so then okay, now it's interesting. Definitely interesting. So can I save it in stack, right? So I get 100 and I save 100 in stack, or rather I save the list as well as a stack. So 100 and 100 occurs on day number 0. Then you get 80. 80 occurs on day number 1, and what you would want is all the guys which are smaller than this, or the first guy greater than this, right? So okay, 80 and then 60. Hmm. So for 60, you would want The guy at the top would the guy at the top has to be the guy which is greater than you. So you have to keep it in descending order, right? So your stack is 180, 60 for 60 again. 80 is the guy which is the problem. Okay, so 60 again also you keep on the stack. Um, and then you get 70. So when you get 70, this is where the tricky situation comes. So when you get 70, um, I think you don't keep 70 on the stack at all. Okay, but when you get 75, then 70 is valuable. Okay. So for every element, you want the next greater. That's correct. So you want next greater on the left. Okay, let's say I am given the array, right? And then try and solve it. So I'm given this array 180, 60, 70, whatever. And now I start. So I start from 100, then I get 80. So for 80, next greater is 100, obviously, because it's the stack I see and it's the next greater. So 80. And then for 60, the next greater is 80. For 70, so for 70, because I'm interested in finding the next greater, 60 will never be the next greater because 70 will be the next greater. So 60 has to be removed out of the stack. Now 60 is gone out of the stack and 70 comes into the stack. And for 70, the next greater is 80. Okay. And for 75, the next greater is not 70 to 70 is now again removed from the stack. You got 75. And the next greater would be, so 75 would be 80. And then for 85, the next greater would be 75 is removed from the stack, 85 is removed from the stack, 80 is removed from the stack, 85 next it is 100. Okay, so I think I got the general gist. Now I don't know whether I need I might need the index, this as well as a stack. So you get this, you also get stack of integer, stack, and then you keep your stack equals to new stack, right? And every time you get an element, first thing you to do is you obviously add it into the list. Fine. And then what's the next thing you do? Now you have to find the next model for this. So you have to also look to push it into the stack. Right? You want to push it into the stack definitely, but only till while. So you do while stack is not empty. Oh, hold on. And stack dot peak. So list dot cat stack dot peak. This guy is smaller than this price. Uh, Equal to also will work, right? So less than or equal to. So yeah, so less than or equal to are the guys that I just remove. So stack dot pop. Okay. Now obviously this will be pushed into the stack, but now there is two things to check. One is if the stack is empty or the stack is not empty. So if the stack is empty, so the other thing to do is int cur equals to start size is list of size. Now if stack dot empty, then your next greater index is stack dot peak. This is greater. Else, okay, so interested index. You do -1, or the previous greater, right? So your this will be a previous greater index. Now you have to return. Now let's see. So yeah, whatever the index is. So current index minus previous index. So current index minus previous greater index. So previous index, if it's -1, then 1 minus. So for example, no. So it's 0, right? And then 0 minus 1 is 1, 1. So yeah, so it's correct. Because current index is list dot size -1, right? Yeah, so current index is 0. 0 minus -1 is okay. So this is fair. I think that's all. Yeah, that's it. So run code. Essentially, this idea of that monotonic stack, we're getting some issues, and the issues are already defined, I guess. Hmm. Okay, runtime error, stack exception. Stack.peak, because you have to do if stack is not empty. Okay, you get a wrong answer though. And let's fix it. So your output is 1, 2, 5, 6, 7, and the answer should have been 1, 1, 1, 1, something like that. Okay. So I guess the stack.pop didn't happen. So the list.cat of stack.peak. If the value of the stack, so in this case, for example, we start with, yeah, the stack.pop shouldn't happen, and it didn't happen, which is correct. So, but then why here 1, 2, 3 didn't change? Because you're not pushing to the stack ever, right? So after this happens, you have to also, maybe not even after this, maybe after this, after here you have to maybe push into the stack. So stack dot push. We have to push always. So I is it uh, whatever the current index is, yeah. So stack dot push. Okay, let's run. Okay, now submit, and it's fine.